The electrical effect of charge was first experienced by Thales of Miletus in around 600 BC, and he noticed that silk rubbed with amber attract a small object, and also the electron word derived from the Greek word whose meaning is amber. Okay, and there are two types of charge: positive charge and negative charge. The naming is given for the convention. Benjamin Franklin named the charge acquired by glass rod when it is rubbed with a silk as positive. Okay, and the charge of acquired by rubber rod when it was rubbed with fur as negative. So an uncharged object can be charged by one of the three methods. First method is conduction electrification. So a uncharged conductor can be charged if a charged conductor comes in contact with the uncharged conductor. Okay, and the second method is by frictional electrification. By this method we can charge a bad conductor, especially by rubbing it with a suitable another bad conductor. For example, when glass rubbed with silk, then the glass becomes positive charge and silk become negative charge. When fur rubbed with rubber, then fur become positive charge, rubber become negative charge. And when the dry hair rubbed with plastic, then dry hair become positive and the plastic become negative. And the third point is charging by induction. So in this method, we can charge a conductor. When a charged conductor comes in contact with another uncharged conductor, then there is a charge separation occurs inside the conductor, and by earthing we can get a charged conductor. Okay, now we are going to understand basic properties of charge. These are the following 3 points I have to discuss here. You have already know that the charge are two types: positive charge and negative charge, and the charge tends to cancel each other effects. Okay, and the first point is additivity of charge. It means the total charge on a body is equal to algebraic sum of charges. For example, if a body contains Q1 Q2 charge, then the total charge will be Q1 plus Q2 plus Q3. And another example is if the body contains 1 coulomb minus 2 coulomb and 3 coulomb charge, then the total charge will be algebraic sum, that is 2 coulomb. And second point is charge is conserved. It means total charge on a body is always fixed. A body loses some charges, then another body must gain that charge, and as a result the total charge of a system will be equal. Okay, and third point is quantization of charge. It means the charge on a body is equal to integral multiple of charges of electrons. So the formula will be Q is equal to Ne, where N is the integers may be positive or negatives, and E is the charge of electrons, and here is the charge of electrons value 1.6 into 10 power minus 19 coulomb. So now we are going to understand Coulomb's law. Coulomb's law is a quantitative assessment to find out the force between 2 point charges. Here the point charges are Q1 and Q2, and the distance between them is R. According to Coulomb's law, the force between 2 point charges is directly proportional to the product of their charges and inversely proportional to the square of a distance between them. And the direction of force acting on these two charges is along the line joining the two charges. And here you can see that the force acting on Q1 due to Q2 and the force acting on Q2 due to Q1 is opposite in direction, but its magnitude is same. Okay, and due to Coulomb's law, we get a formula F is equal to K Q1 Q2 by R square, and where K is equal to 1 by 4 pi epsilon naught, whose value is 9 into 10 power 9 Newton meter square per coulomb square, and epsilon naught is known as absolute permittivity, whose value is this. Okay.